This is lesson number 70 in Algebra 1, Probability and Designated Order. So let's start with probability. Alright, probability is used when you're playing games of chance. And it's, I guess the most common would be if you're talking about gambling. And you're trying to figure out what the chances are that you're going to win. That's the probability. So if you have like an 80% chance of winning, your probability of winning is pretty high. You have a good chance of winning. If your probability is 20%, your chances of winning are a lot slimmer, and you may not have as much chance to win. You may not want to sacrifice your money or anything in order to take a chance on winning. So that's pretty much what probability is. And we're going to look at like flipping coins, rolling dice, or selecting cards from a deck, or maybe you've got a bunch of marbles in a bag and you want to know what the probability that you're going to reach in there and pull out a red marble. So that's what we're going to look at. So let's first of all look at coins. So when you flip a coin, you have a choice of getting a heads or a tail. So what are the chances of getting a head? Well, there are two options there, a head or a tail. So you have what we usually say is a 50-50 chance. We have a 50% chance of getting heads. Or what are our possibilities when we roll our die or when we flip our coin? Our possibilities go down the bottom, and what we're looking for goes on the top. So we're looking for heads, so we have one chance out of the two of getting heads. So 1/2 is a 50% chance. Alright, one of the things that you'll notice when you're doing probability is you will always get a fraction, and your fraction will always be a number between 0 and 1. And then when you convert it, when you move the decimal place over, you can make it get a percent. So 1/2 is really 0.5, right? And when you make that into a percent, you move the decimal over 2, and it becomes a 50%. Alright, so you can change that to a percent if you'd like. In this section, I don't think we're going to do that. We'll just leave it as the fraction right there. Okay, when we're looking at something like rolling a dice. Now, rolling a dice, you have a choice of getting a 1, a 2, a 3, a 4, I know you all know this, a 5, and finally a 6. Alright, so if we roll a dice and we want to see what the probability of us getting a 3 would be, well, how many 3s are in this whole list? There's 1. How many dice, or how many chances, or what are my choices of what I'm going to roll? I can get, when I roll this dice, a 1, 2, 3, 4, 5, or a 6. I have 6 different possibilities. So the possibilities go on the bottom. What you're looking for goes on the top. So you have 1 out of 6 chance of getting a 3. How about, what are your chances of getting a 5? Well, there's 6 choices, and you only want 1 of them. What about, let's say that we're going to roll our dice, and we want to get something that is, oops, don't want to make that go away. We want to get a number, let's say, between, or a 1, 2, or a 3. We don't care which one it is, but we want to get a 1, 2, or 3. What are the possibilities or the probability? So we still have 6 options. The number of, whether you get a 1, 2, 3, 4, 5, or 6. And then this is what we want. There's 3 different choices there that we're happy with. As long as it's a 1, 2, or 3, we're happy. So then 3, 6 reduces to 1/2. What if I want a 3, 4, 5, or 6? I'll be happy if I get a 3, 4, 5, or 6. Well, I still have 6 chances, or 6 different options, and which ones do I want? I want one of those 4. So I have 4 different ones that will make me happy. It doesn't matter which one, I'll be happy. So that reduces to 2/3. And that's pretty much what probability is. Now, the one thing that's really, really important about probability is what is called independence. Now, each of these are independent of each other. So, for example, if I get a head or a coin and I have a choice of heads or tails, and let's say that I flip the coin 3 times, and all 3 times, there's chance 1, 2, 3. Okay, there's my 3 tries. All 3 tries I get a head. Now, on the 4th try, what are the chances that I'm going to get a head on that one? Alright, so a lot of times people are going to look at that and say, well, you don't have much of a chance because you got heads here, here, and here. The coin does not care what it got in the past. It doesn't matter. It's independent. This choice here will be a head or a tail, irregardless of what these were. The coin does not care what it had done in the past. So these have nothing to do with it. The chances of getting a head here are the same as the chances of getting a head here, here, or here. It's 50-50, or 1 out of 2. There's your choices, heads or tails, and you're only going to get 1 flip, and you're going to get 1, either a head or a tail. So the chances are still 50-50 that you're going to get a head. It's 50-50 on whether you get a tail. So don't let the story problems that say, we got heads 3 different times, what's the chance on this one? We don't care about that. We're just looking at the flip that we're about to do. Okay, so there is some vocabulary that you need to know. When you are doing one of these, when you are flipping the coin, drawing a marble from a bag, or whatever, those are called experiments. And when you get your result, when you flip your coin, and let's say you get a head, that is called an outcome. Okay, I would put those down in your notes. That's an outcome. Okay. The set of outcomes, or the set of probable outcomes, is called your sample space. So if you have a head or a tail possibility, that is your sample space. That is where you're going to get your possible outcomes. So when you're flipping a coin, your sample space is heads or tails. Your outcome is whatever you get. In this case, you might get a tail. So that's your outcome. Alright, so let's go ahead and look at a couple of these examples. They start off fairly easy. So a fair coin is tossed 3 times. I'm looking at example 70.1. Fair coin is tossed 3 times and comes up heads every time. Okay, remember, we don't care what it did in the past. What is the probability that the next toss will come up heads? Well, the probability that you're going to take a coin and flip it and it come up heads, you have 2 options. It's going to come up a head or a tail, and you want it to come up heads. That's it. Example 70.2. 6 green marbles, 8 red marbles, and they're placed in an urn. An urn is kind of like a jar. That looks a lot better than my drawing, but that's what an urn is. 1 marble is drawn, then dropped back into the urn. Then a second marble is drawn and dropped back into the urn. Okay, we don't care about that. It doesn't have anything to do with our chances. Both marbles were red. Again, we don't care. If another marble is drawn, what is the probability that it will be red? Okay, well, how many marbles are in the bag? So when we reach in our hand in there, we have a choice of getting 1 of 14 marbles, because 6 and 8 is 14. Just like up here, we had an opportunity when we flip our coin of getting 2 options, a head or a tail. Alright, so 14 is on the bottom. We're looking for red ones. So we're going, this is the number that we want. We want one of the red ones. So that number goes on top. And then we just reduce. So 4 out of 7. Okay, so that's the probability, 4/7, that we will be able to get a red marble. Is that a pretty good chance of getting a red marble? Yeah, it's over 50-50, so it's not too terrible. Alright, so let's look at dice. We're going to roll dice, and again, when we roll our dice, we can get a 1, 2, 3, 4, 5, or 6. So we have 6 possibilities when we're rolling the dice. A single die is rolled 3 times. The results are 1, 4, and 1 in that order. Okay, again, we don't care. That doesn't matter. What is the probability that the next roll will produce a number greater than 2? Okay, so we have 1, 2, 3, 4, 5, 6. When we roll our dice, we can get one of those 6 possibilities. We want a number greater than 2. Means 2 doesn't work, has to be greater than 2. Those are the ones that I want, 3, 4, 5, or 6. Alright, so what are my ultimate chances when I roll my dice? How many possibilities do I have? I have 6 because there's 6 faces to a dice. What do I want? A 3, 4, 5, or 6. How many numbers are there? 4. So that means I have a 2/3 chance of getting the dice that I want. Okay. Now let's do something a little bit different. So this one has to do with rolling 2 dice. And when we roll 2 dice, we can get a 1, 2, 3, 4, 5, 6 when we roll the one, or a 1, 2, 3, 4, 5, 6 when we roll the other one. So let's say we roll the dice. In the first dice we get a 4. In the second dice we get a 3. So if we add those 2 up, we get a 7. So how many chances of getting a 7 do we have? We have 1, 2, 3, 4, 5, 6. Because we can get a 6 and a 1, a 5 and a 2, a 4 and a 3, a 3 and a 4. Okay, so see how that works? These are the numbers that I can get when I roll. So if my first dice, okay, first, I get a 3. On my second one I get a 6, and where those meet is the sum of the two. So I get a 6 here and a 3 here, add those up and I get a 9. So that's what these numbers are, is when you add up the columns with the rows, then you'll get that number. Okay, so they say 2 dice are rolled. What is the probability that the sum of the numbers rolled is 7? So what is the probability that when I roll the first one and get a number, and I roll the second one? So let's say I roll the first one and I get a 3. And I roll the second one and I get a 4. Well, when I add those up, I get a 7. If I roll the first one, I get a 2, and the next one I get a 5. Add those up, I also get a 7. But what if I roll the first one, I get a 3, and the second one I get a 6? Well, then I get a 9. Okay, so what I'm interested in is the possibility or the probability that when I add the 2 numbers up, I'm going to get a 7. Alright, so that's where this table comes in handy, because I can just look at how often 7s occur here, count them up, and say, oh, 6 times I'm going to get a 7. Well, 6 is not a probability, because remember, the number you get for a probability has to be between 0 and 1. So I have how many possible options? Well, if you count all of these numbers, those are the possible options, there's 36. So there's 36 possible options when I roll my dice. And I'm only interested in how many 7s there are. There are 6 7s. So that means I have 1 in 6 chance of rolling my dice in such a way that I get a 7 when I add them up. So we use the letter P for probability, and then we put the number that we're looking for there. So the probability of getting a 7 is 1/6. Okay, what is the probability of getting a 4? Okay, the possibilities are going to be 36. Whenever you roll 2 dice, it will be 36. So now let's look and count 4s. 1, 2, 3. So we have a chance of, when we roll it, getting it 3 times.